Okay, so now let's talk about the angle measures inside of a triangle. We have two different types of angles with triangles. So the first one, the one we use the most often, are the interior angles, and this is something you would have learned in middle school. So I drew a triangle that was the intersection of three different lines. The interior angles are the ones that are on the insides of the lines. Kind of shade them in pink. Okay, so those are the interior angles. An exterior angle is what you get if you extend one line of a triangle, so it goes past the vertex of the triangle. So that could be right here, and right here. Now, you'll notice that that original picture kind of looked like a pinwheel, how they were all kind of going clockwise. If I had extended them the opposite way and all of them are going counterclockwise, you would have an exterior angles going that way. So there's actually two exterior angles at each vertex. Okay, so then there's a triangle sum theorem that says the sum of the measures of the interior angles is always going to be 180. Okay, so if you know two angles of a triangle, you can figure out the third angle. So in this case, you would add up the two you have, 100 plus 30, and subtract them from 180. So 100 plus 30 is 130. 180 minus 130 is 50. Okay. For this one, we know two of the angles. This is 45, that one's 90. So you can do the same thing. Do 180 minus the two angles that you have added up. 45 plus 90. So that's 180 minus 135, which is 45. And let's go to the back page. So we're going to use, we're going to figure out what all of these different variables are. So this says figure out what's the measure of angle A. Well, looking at the picture, they told us that angle A is 59 degrees. Okay. Angle ABC is this angle up here. It's equal to these two pi pieces added up. So 43 plus 49 gives us this whole angle is 92 degrees. So I know that if I add up the three angles of a triangle, they have to add up to 180. So now we're going to substitute in what we know. So angle A is 59. Angle ABC is 92. And angle C is over here, that's our Z. And they have to add up to 180. So if I add those up, 59 plus 92, I get 151. So now we have 151 plus Z equals 180. We would subtract 151 from both sides. So 180 minus 151. You'll get Z is 29 degrees. I'm going to draw that in the picture to make this a little easier. Okay. So the next question is, what's the measure of angle BDA? BDA is represented by X. I'm going to put an X in parentheses. They're basically saying, what does X equal? And I can ignore this part of the picture. Okay, so I have two angles of the triangle. I'm trying to find the third. So you do 180 minus the two angles added up. 43 plus 59. So that gives us 180 minus 43 plus 59. And that is 78 degrees. Okay, so this one's 78 degrees. Now you have a choice. You could figure out why, because we know two angles of the triangle. And I know all three of those angles have to add up to 180. Or you can do x and y are a linear pair, so just those two have to add up to 180. So that's what I'm going to do. I'm going to say 180 minus 78, and that will give me 102 degrees. You can check yourself. 102 plus those other two angles, 102 plus 49 plus 29 should give us 180, and it did. Okay, so now the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. So I drew a picture over here. Angle 1 is your exterior angle in this picture. Remote interior, interior means inside, so there's three inside angles of a triangle. The remote means far away. If you travel to a remote area of the world, you've traveled somewhere far away. So if I think about the two remote angles that are associated with angle 1, two angles farthest away, so angle A and angle B. So that means the measure of angle 1 is equal to the sum of the two remote interior angles, measure of angle A plus the measure of angle B. Okay, so these next problems. Circle the number of each exterior angle and draw a box around the number of each remote interior angle. So the exterior angle in this one is number 3. And then the two remote interior angles are the ones on the inside of the triangle farthest away. So here and here. So the same here. You try it first. Circle the one that's the exterior angle and then put a box around the two remote interior angles. You should have gotten this is exterior, this is interior, and that is remote interior. Okay, so now let's use this. Two angles of a triangle measure 53 degrees. What is the measure of an exterior angle at each vertex of the triangle? So first step, label the interior angles 53, 53, and A. So the two that are marked congruent have to be the ones that are 53. So 53 degrees and 53 degrees. And then the one that's left over, we're going to call it A. Okay, so we did step A. Step B, label the exterior angles adjacent to the 53-degree angles as X and Y. So that will be this one and this one. Label the third exterior angle Z. Solve for each variable. I like to go in alphabetical order, so I'm going to start with A. For A, you just pay attention to the interior angles. I know they have to add up to 180. So for A, I will do 180 minus the two angles I know added up. And that'll give me A. So 180 minus 53 plus 53 means I have 74 left over for A. So A is 74 degrees. Okay, so X and Y are linear pairs with congruent angles, so they're going to be equal to each other. So let's figure out what they are using our new theorem that we just learned. So X will be equal to the sum of the two remote interior angles. So X is next to this 53. So the two interior angles it is not next to are these two. So X will be equal to 74 plus 53. So that will be 127 degrees. Okay, and Y will also be 127 because it's, like I said, it's a linear pair of these congruent angles. So X and Y have to be the same. Or you would get Y by adding up its remote interior angles, which are 53 and 74. So I'm going to put, oh my goodness, my son keeps calling me. Y equals 127 degrees. Okay, so then for the last one, Z is also an exterior angle, it'll be equal to its two remote interior angles added up. That's going to be the two 53s. So 53 plus 53 will give us 106. Okay, so those are all the answers for example 4. On to example 6, this is something that the ACT and the air test likes to throw out there because it looks like an easy question at first until you realize you have to remember the exterior angle theorem in order to solve this problem. There's no way to figure out this third angle on the inside of the triangle, so you have to remember that this exterior angle equals these two added up. So that relationship can be written as an algebraic equation. We write the exterior angle equals the sum of the two remote interior angles, 2x plus 65. Now to solve that, I want all the x's on the same side, so I'm going to subtract 2x from both sides. We get 1x plus 25 equals 65. Subtract 25, you will get 65 minus 25. It's 40. Okay, so then the direction said find the measure of angle PQS. So we're almost done. The measure of angle PQS is what I get when I substitute 40 in for the x. So 3 times 40 plus 25 will give me 120 plus 25, which is 145 degrees. And that is your final answer. Okay, so I want you to try this practice part. Pause your video, do that, and then turn your video on to check how you did. So this says, use the triangle at the right, fill in the blanks below to explain how the triangle exterior angle theorem makes sense based on the triangle angle sum theorem. So this is basically a real informal proof that we're writing. So the first part says, what does the triangle angle sum theorem say? It says that if I add up three angles of the triangle, it will equal 180. So they put in the angle 2 right here. The other interior angles will be the measure of angle 1 plus the measure of angle 3. Okay, add up the three angles, you'll get 180. The linear pair postulate says that two angles that make a linear pair are supplementary. So angle 2 and angle 4 are a linear pair. So now, this said, since these two are basically the same formula, plus measure angle 2 equals 180 on both of them, that these two parts that I filled in have to be the same. That's kind of a real overly simplified transitive property. So that is why that's correct. So now take this time to practice some of this on your own.